In this video, I want to discuss the idea of normal distributions. I'm going to start by looking at what's known as the standard normal distribution. For the standard normal distribution, the PDF is given by phi of z, and this is 1 over the square root of 2 pi times e to the negative z squared over 2. The CDF, which is given by a capital phi of z, is just the integral from negative infinity to z of the PDF. And this is a very, very hard integral to compute. In addition, for this normal distribution, my mean is 0 and my variance is going to be 1. And this is the standard normal distribution. So let's look at the general normal distribution. The general normal distribution, this is denoted by x, is n of mu comma sigma squared. So it's the mean and the variance. The PDF is given by 1 over sigma, so the standard deviation, the square root of variance, times phi of x minus mu over sigma, where this phi is the PDF of the standard normal distribution. And the CDF is given by capital F of x is equal to capital phi of x minus mu over sigma, where this capital phi is the CDF of the standard normal distribution. So when we're dealing with general normal distributions, we are given our mean and our variance, or the mean and standard deviation, and we have these forms of the PDF and the CDF. However, it is important to note that this is very, very, very difficult to integrate. So this is very hard to find. There are tables that give you values for the normal distribution, or you can use something like R or RStudio. Here's the general graph for the PDF of the normal distribution. We have our x-axis down here, and it is this nice bell curve. The midpoint right in the middle, this is the mean. And the standard deviation determines how tall and skinny this thing is, or how wide and flat it is. The curves all do look like this general form, but they may be taller and thinner, or they may be wider and flatter. With the normal distribution, we do have this 68, 95, 99.7 rule. And what it says is that if I look within one standard deviation, so one standard deviation above the mean and one standard deviation below, this holds approximately 68% of my data. For two standard deviations, 2 above and 2 below, it holds approximately 95% of my data. And then if I look at 3 standard deviations above and below, this is going to hold approximately 99.7% of my data. So using that, I can get rough approximations for this. However, to get more exact approximations for a normal distribution, we will need to use either the tables or R in RStudio. And in the next video, I'm actually going to look at calculating normal probabilities using RStudio.